Two frontier labs have now shipped advanced cybersecurity AI systems through the same exclusivity-based release pattern. 3 weeks ago, that was exclusively Anthropic's approach, but yesterday it became a pattern when OpenAI chose to follow the same playbook. In the same news cycle, a published method for translating what is happening inside a model into English, a library of fluorescent proteins designed from scratch, and the empirical record of 2,475 cities cutting the link between growth and burning. Let's walk through it today. OpenAI shipped something called Daybreak yesterday. It's an AI agent that you point at a code base, and it does what a small army of security researchers used to do. Scans for vulnerabilities, reasons about how an attacker would chain them, and proposes patches. The system, though, isn't for sale. There's no API, no consumer version. OpenAI is releasing it through what the company calls a controlled deployment to a vetted set of enterprise customers, with the contract spelling out who holds the capability and under what conditions access end. A few weeks ago, Anthropic did the same thing with Mythos. Same type of gating, same release pattern. And you can't buy it either. Two of the three leading frontier labs have now independently arrived at the same conclusion. Capabilities that can find 0 days at scale cannot ship as ordinary products. They need a contract layer that the lab can audit and pull. The labs are writing the operating manual themselves. A living contract negotiated continuously between a lab and a small list of customers about a capability whose downside cases have no precedent. That's the form that hardened into a pattern yesterday. So what does this mean for you? If you've read a headline about a ransomware crew taking down a hospital network, for example, or a regional water utility, or a school district, or recently, Canvas, the capability that OpenAI just gated is the capability that deployed defensively narrows the attack surface. A regional hospital network can find the SQL injection path before the ransomware crew does. The same capability that worried the labs enough to gate it is the one that, in defender hands, makes ordinary infrastructure harder to break. And the gating is real. But in the same news cycle, Google's threat intelligence group confirmed the first documented case of criminal hackers using an AI agent to discover a 0-day in the wild. The offensive curve is already moving, which means the two-tier pattern is the labs trying to put defensive capability into trusted hands faster than the offensive capability proliferates outside of them. A deeper look at this release pattern question is in today's Sentry Report. But what I want you to hold on to here is that the pattern hardens as governance form and dissolves as captured advantage at the same time. Each controlled release publishes more of this technique, the audit shape, the prompts, the benchmark numbers, the postmortems than it actually withholds. Mozilla published a public Mythos audit harness on May 8th that defenders outside any vetted list can now use. The UK AI Safety Institute published benchmarks showing GPT 5.5 matching Mythos on advanced cyber tasks. The gating window is closing from both sides. Now, the reason gating became the form that these labs converged on is the gap between what a frontier model can do and what its operators can verify it's doing. And that has been the central anxiety of the deployment era here. Audit logs catch surface behavior. Red teams catch what they think to test for. What you actually want, though, is something that reads what's happening inside the model, the activations themselves, and reports it back in language that the operator already speaks. Anthropic published a paper recently on a method for doing exactly that. They call them natural language autoencoders, which is a mouthful, so let me give you the idea. Take a snapshot of what's lighting up inside a model as it processes a prompt. Train a small network to write an English description of that snapshot, and then train a second network to reconstruct the original activations from the description. So if you can feed the description back through and get the model to behave like it did initially, then the description is treated as faithful. The team reported that the resulting sentences track concepts the model is genuinely using, rather than rationalizations generated after the fact. 5 years ago, the dominant view inside the field was that the internals of an LLM were too high-dimensional and too tangled together for any compact English description to really capture them. You could probe for specific concepts, but you could not translate a whole layer state into a paragraph. Anthropic just reported that the reach is shorter than assumed. The capability is early, The descriptions are sometimes vague and sometimes wrong, and Anthropic was very explicit about that. But what the paper does demonstrate is that the translation problem is solvable. It's a technique that works well enough to publish, and now every other frontier lab has a template for building on that same capability. The same technique can be turned to open weight models as well, that already exist outside any single lab's control. Stitch that back to the cyber release story that you heard a second ago from me. The reason that two-tier release exists is that the lab cannot verify from the outside what its own model is actually reasoning about when it surfaces a vulnerability or proposes a patch. If interpretability becomes portable across the field, and Anthropic's paper is the start of that portability, the constraint that controlled access was substituting for starts to loosen, gradually on a trajectory that you can see. The verification layer the labs were performing through contracts is becoming something operators can hold directly at the same time. All right, shifting away here, different domain. A team at the Howard Hughes Medical Institute's Janelia campus, working with David Baker's lab in Seattle, published something yesterday called NovoTags. This is a library of fluorescent proteins designed from scratch by a generative model. Quick context here. For 30 years, when a cell biologist wanted to watch a protein move through a living cell, they used a fluorescent tag, a piece of protein that lights up under a laser. The most famous one, green fluorescent protein, comes from a jellyfish. Most of the others come from corals or sea anemones. Evolution decided what colors were on the menu. Researchers then worked with what evolution produced and slowly mutated those proteins to push into other colors. Two proteins emitting at similar color wavelengths bleed into each other when you try to image them. The number of different proteins that you can watch simultaneously then inside one living cell has a hard ceiling, somewhere around 5 or 6 channels in most labs. But here's what the Janelia team did. With an RF diffusion class model, they inverted the problem. They told the model, design a protein structure that binds this specific small molecule fluorophore cleanly. The model proposed structures. The team built them in the lab, and the structures worked across colors that have historically been hard to reach without bleed-through or photo-bleaching. The way live cell imaging worked for decades was, here are the colors that evolution happens to have given us, work with those. The way it works after this paper, though, here's the color you actually want, design the protein to fit it. The reagent that used to be a constraint becomes a specification. Multicolor live imaging is how cell biologists watch what proteins are doing at the same time in the same cell. Lifting the channel ceiling is the difference between watching just one process in a living cell and watching 5 processes interact, combined with the broader trajectory of AI-designed binders and enzymes. This points to a working laboratory where the off-the-shelf molecule has been replaced by one designed for the specific question being asked. And that's a big deal in science because, again, traditionally we're dealing with what has been handed to us. We are starting now to be able to design what we need to fully understand. And another way to kind of understand the immensity of this breakthrough, if you're only able to see one thing, one aspect, one angle of something, then your view is, of course, very limited. But if you're able to even add one alternate angle, then suddenly your view opens up by quite a lot. And that's the breakthrough that we're doing here. The Janelia team released the designs and the protocols publicly. What used to be a slow accumulation of fortunate discoveries is becoming something that a lab can request to specification. All right, one more for today. A Nature Cities paper published yesterday mapped fossil fuel emissions and economic outputs across 2,475 cities around the world. The data covers from 2012 to 2022. And here's the finding. Roughly 4 out of 5 of those cities, about 80%, grew their economies during that decade while their emissions stayed flat or fell. Slow down on that here. 80% of the cities studied across income levels, across geographies, across sizes, Europe, North America, East Asia, Latin America, GDP up, fossil fuel emissions not up with it. Now, the authors were really careful. They noted that even decoupled cities aren't cutting fast enough to hold the warming under the 2 degrees goal. They noted that consumption-based accounting, which attributes emissions to the city consuming the goods, tells a more complicated story for wealthy cities importing manufactured goods. They were not claiming that the climate problem is solved. What they were saying, though, is that the link between a city growing and having to burn more The assumption that has structured climate debate for 40 years has empirically broken in most of the world's largest cities. The mayor weighing whether to permit a new gas plant in 2025 faces a fundamentally different cost calculation than the same mayor in 2005. Solar got cheaper, storage got cheaper, electrified heating and transport got cheaper. The math has stopped favoring the gas plant in most jurisdictions, and ordinary procurement decisions began producing the outcome that decades of climate advocacy had struggled to produce on its own. So if you live in a city, you are quite possibly already inside this decoupling without knowing it. The electricity you used yesterday came from a generation mix that is, in most of the cities studied, less fossil intensive than the one in the wall socket 10 years ago. The cost curve of the alternative made the procurement decisions for you. The cities in this dataset are not all heroes of climate policy. Many decoupled while pursuing growth as their final priority. They got the decoupling as a side effect because the cheaper energy option was also the cleaner one. 80% of 2,475 cities. The same dynamic showed up in another corner of yesterday's news cycle. Ford spun out a grid storage business called Ford Energy, built on the lithium iron phosphate cell capacity that the automaker had already stood up for electric vehicles. 20 gigawatt hour annual manufacturing pipeline. The cells are the same as the ones in a Ford F-150 Lightning. The integration is tuned for sitting next to a substation instead of going down the highway. The marginal cost of adding the second product to the first is small relative to the capital already spent. The factories built to electrify cars are now the factories supplying the storage layer that the grid is racing to build. Pull all of that together for a minute and we'll close the day out here. A capability that can find zero-day vulnerabilities at scale shipped through a controlled access release for the second time in just a few weeks from a completely different company. A technique that translates the internal state of a frontier model into English sentences that a human can read got published. Portable to every other lab and to open weight models outside any single lab's control. A library of fluorescent proteins designed from scratch went public, with colors evolution never produced, and protocols any lab can request. The empirical record of 2,475 cities decoupling growth from fossil fuel emissions came in at 80%, and an automaker spun its EV cell capacity into a 20 gigawatt hour grid storage business. If you went looking for the story underneath all of that, the surface read is that the leading labs are consolidating control of frontier capability and the rest of the system is simply racing to catch up. And that read is available in any business publication you'd care to pick up. It's also, I would argue, the wrong read of yesterday's evidence. Instead, what yesterday's evidence shows is that access to capability is widening at a rate the gating decisions were not designed for. The Daybreak release publishes audit techniques defenders will use within weeks. The interpretability paper hands every lab in the field the template that Anthropic spent months building. The fluorescent proteins are open with their design protocols. The cost curve of clean energy is making city-scale decarbonization a procurement decision instead of a moral commitment. And the access to scientific literature that Elsevier sued Meta over yesterday. A researcher in Lagos or Lima or Jakarta who could not afford a subscription now has a working access to the literature that the paywall was built to deny them. That access is not going backwards. The lawsuit is a legitimate copyright claim, but it is also, by its own evidence, a record of the toll booth losing the conditions that made it operate. Now, there's friction in all of this. Colorado is rewriting the AI accountability law that XAI is currently suing the state over, for example. Criminal hackers are using agents to find 0 days. The capability is moving fast enough that the institutions adapting to it are themselves having to adapt continuously, not just once. But the direction the access is moving when you look at the day in full and when you zoom back to look at recent news in full, that is widening. The substrate underneath medicine, energy, intelligence, and the infrastructure that supports all three of those is becoming legible and tunable at resolutions that the prior decades simply did not have. So here's what I'd look for over the next several weeks. A third frontier lab announcing a controlled release, cyber-capable system that confirms two-tier as the default form. An interpretability technique applied to a deployed open weight model in a way that nobody is currently in a position to gate. A new fluorescent tag designed against a specific biological question instead of simply inherited from a jellyfish and deployed to learn something new and incredible about what's going on inside cells. The economic decoupling deepening in the next year of city data, because all of those will happen and the others will follow shortly thereafter. If you're a researcher who couldn't afford the journal subscription, the literature is reaching you anyway. If you're a defender who couldn't access a frontier cyber model, the audit techniques are reaching you anyway. If you're a cell biologist who's been waiting on a fifth clean channel to learn something you need to know, the protein is reaching you anyway. If you're a city procurement officer comparing a gas plant to a battery, the price tag is reaching you anyway. The day's evidence is that the answer to who gets to be a scientist, a defender, a researcher, a builder is being shifted by the cost curves and the publication choices and the contract architectures the labs and institutions are publicly releasing are being undermined. The shift is in the running record. We'll see you tomorrow.